Welcome to Systems Programming. I'm Gates, and I will be your guide through this course. Unfortunately, we'll have to work with the language C. C is a portable assembly language. It's closely tied with the Unix system and is a practical language. Of the high-level languages, C is one of the lowest.
How dare you call me low-level? I'm a very capable, widely used, fully grown programming language.
Low-level just means you are closer to base code. That is, you're closer to the binary that all electronics operate on. Being low-level has advantages and disadvantages. Even though C is low-level, there is still a lot that goes on beneath it. When you're only dealing with applications, there's a lot of magic that happens between you and the reality of it. It's time to look behind the curtain.
But I like the magic. We don't need to look at those things. Those things are scary. This is why we need the curtain to begin with.
This is the compilation system. It's how what you write in a C file gets transformed into a language the computer can execute. It's kind of scary how each dot creature has more teeth than the last. The preprocessor modifies the initial program by finding the lines that start with pound and inserting code from other files that the line refers to. This transforms a .c file to a .i file. The compiler phase translates it into an assembly language program. This is the stage that does most of the work. Many different languages translate their code at some point into a .s file. The assembly phase translates the .s text file into a .o file. This is a relocatable object program or a binary object code file. The linking phase transforms the file into its final stage. This merges a file with a printf.o file or whatever it needs in order to be complete. This is an executable code type of machine code. Next, let's talk about the hardware of a typical system. Buses are electrical conduits that transfer words. These chunks of bytes are usually fixed sizes. The most common sizes are 4 bytes, 32 bits, and 8 bytes, 64 bits. I/O, or input-output devices, connect the computer to the user. These include the mouse, keyboard, display, and disk. Each of these uses a controller or adapter to connect to the I/O bus. The main memory is a short-term memory that holds the program that's running and the data that it's interacting with. It interacts with the CPU in what's called a fetch-execute cycle. Physically, main memory is made up of dynamic random access memory, or DRAM. Logically, this memory is organized as a linear array of bytes. The processor, or CPU, is what interprets or executes the program. This and the graphics card are what sometimes overheat. The program counter, or PC, points to the next instruction to be executed in the program. This program is being stored in main memory. This word-sized device runs the entire time your computer is on. We think it operates by an instruction execution model called its instruction set architecture. In modern times, networks are a huge part of what we do. We are constantly using the network adapter to connect to a network. The network operates as another I/O device.